Good afternoon, everyone. Welcome back to another exciting day in mathematics. Warm-up 101 is on the screen. I only gave you the mesh variation just for practice. I took off the other practice because I want to save time for the lesson. We're moving on to another portion. Yes, we are. Oh, yeah. We're getting there. Yeah. No. Copy that and go. All right. Thank you very much. Yeah, they're behind the screen. Yeah. I think there's two of them. All right, copy the agenda for today, please. Warm-up 101. We're still continuing with discrete probability distributions. And today, only 2 problems for home plate. Only. Thank you, Mr. Q. You're welcome. And get a Cornell note ready, please. Also, if you haven't turned in last night's home play on the practice that we did yesterday, do that, please. All right. Our objective for today, I can define and compute discrete probability distribution. I can define and compute discrete probability distribution. We're still on the same concept, and the reason being is that the different distributions need to be addressed. We already covered a couple. Today we're going to introduce a new one. So here we go. So once again, we've covered our basic probability definitions. We talked about variables. We're still focused on discrete variables. We talked about distribution. We talked about the formulas for distribution. And then we started with our first, after our regular distribution, we started with binomial distribution. And here's the formula. We covered that. We went into multinomial distribution. So you remember the difference between a binomial distribution and a multinomial. Not the formula, but what's the difference from one to the other? What's the difference from one to the other? All right, let's see, enlighten us, please. Pedro. Yeah, binomial, there's only 2, and multinomial, there's more than 2. Today, we're introducing a new one. Write this down. It's known as Poisson distribution. Poisson distribution. Now, this one, it's not because we're going to be dealing with Poisson, but it comes from a mathematician. You don't have to write this down, just a quick in passing to give him credit. French mathematician, worked on calculus, basically did a lot of work in integrals. Also, he worked on electromagnetic theory. And today, we're going to see some of his probability work that came about. And here's the formula. Write down the formula, please. And basically, this distribution is used, let's see, binomial, we said that it's 2. And then Pedro said the difference from that one to the new ones because the multinomial is more than 2. Poisson distribution is used when there's multi or more than 2, but there's greater amounts of numbers that are involved. So notice that yesterday and the day before we only did like P of 1, P of 3, 4, 5, just like a handful. Today is going to be like a bunch of numbers. Yay, right? Copy that, please. I'll give you some time. Shall we? Yes? So, any explanation on the components? Talk it over with your neighbor to make sure they understand each piece. It's lambda, yes. And lambda for this formula means the mean. See what I mean? So lambda. The other number that you should be familiar with, those of you that were with me in Algebra 2, towards the end of the year we talked about E, remember E? And the approximate number, that's 2.71, which the one we use, but I want you to use 2.7183. That's going to be the decimal value for E. Make sure you write that down, please. E is 2.7183. All right. Here we go. Example Q. It reads, if there are 200 typographical errors randomly distributed in a 500-page manuscript, find the probability that a given page contains exactly 3 errors. Copy that one completely, at least so you can have one whole example on your notes and give you some time. All right. So, with that said, let's start by writing our items. We got X. We got lambda. And we got E. And E by now it's 2.71 what? 83. Okay, we got that. All right. So from here, tell your neighbor what X is. What are they asking us to find? Very good. 3. All right. So which means that what's left should give us our what? What does lambda stand for? All right, so write 200 over 500. And let's get that in decimal form. It's what? 0.4. Bam, thou, let's go. Remind me of me and Kinder. All right, 0.4. Now that you have your values, let's get our formula going. P. So we got 3.4. Then we got 2.7183 to the power of, part of the formula is a negative, what? 0.4, thank you, times lambda, which is 0.4, and 0.4 to the third power, over x factorial, which is 3 factorial. All right, computers compute. .0071. Give me the next decimals after that.
5.
Which means we can round this one to 2. All right, from 1 to 5, how comfortable are you with these? Okay, good. Good participation. Anyway, send me your notes, see what you did. Let me elaborate a little bit on this to see if you remember. Question. Can we have negative exponents? I mean, this is correct, but I'm saying, can we have negative exponents? So then what do we do to change this to a positive exponent? Who remembers from Algebra 1 and Algebra 2? Yeah, send it to the denominator. You guys remember that? So this becomes to the 4th factorial 3, yes. Yeah, is everybody following? Yes. 0.4, yes. 0.4 to the 3rd times 2.7183 to the 4th times 3 times 2 times 1, or 3 factorial, and just simplify the rest. Yes? All right. Copy this one, example mega cube. Well, actually, this one you don't have to copy. Let's get started with the formula and start writing our items first. And it reads, if approximately 2% of the people in a room of 200 are left-handed, find the probability that exactly 5 people are left-handed. Okay, so then let's start with our X. Lambda. E. All right, so what is X, everyone? 5. How do we get lambda? Because now they're giving us a percent and 200.
4 over 200.
What is it? How about 0.02 times 200? Be nice. Yes, let's try and get decimals and be nice. Yes. So, decimal form of that is what? 0.02 times 200. 4, thank you. All right, now that you have your values, set up your formula, please. I'll give you some time. Copy and go. Check your work. So basically, we're bringing this piece down to the denominator and changing it to a positive. Yes? Now let me take you back in time. Here it goes for those of you that forgot. Whenever you have a negative exponent, you change it into a positive. You set it either to the denominator or to the numerator. So when it's like this, then it's to the denominator. However, if we have something like that, to change into a positive, it goes to the what? Numerator. 2 to the 3rd over 1, which is 8, and so on and so forth. All right. Who's got me some decimals? Matthew, what'd you get? 153. Oh no, sorry. 15 what? 6. Go one more decimal. 3. Hands if you got that. If you did 2, that's fine, I guess. All right, from 1 to 5, how comfortable are you up to right there? Okay, 5 4s and a 10 over there, all right. All right. Now look at this one before you start writing down stuff. Look up example super Q. Reads. A sales firm receives on average 3 calls per hour on its toll-free number. For any given hour, find the probability it will receive the following. At most 3, at least 3, and 5 or more. This is a little bit tough, but I think it's doable. So before we start writing down, this is what I want us to do. This is very similar to the one we've been doing so far. Talk it over to your neighbor, let them know what this means. What does that mean? Let's see, Jet, enlighten us. What does that mean? Very close. Thank you. 0, 1, 2, and 3. That is correct. All right. Hold on. Hold your horses. You know what? Let's do the work for this. Write that down, please. 0, 1, 2, 3. We're going to do A first together. Hurry up. Which means I need to write what? P of, what's my first one? 0. And what's the lambda? What's the average? 3. And of course I need P of 1, lambda 3. P of 2, lambda 3. And P of 3, lambda 3. All right. Let me pause this. All right, so I'll give you some time to compute that really quick, because that's, from here, we're going to see how it works for these two at the end. Go. Okay, who's got a P of 0, lambda 3? Samuel, you got it already? 0.0498, that is correct. Who's got P of 1, lambda 3? Eric, what'd you get? 0.1494, that is correct. Who's got P of 2, lambda 3? Zach, you got P of 2? Okay. Mel? All right, I'll give you guys a little bit more time. All right. What'd you get for P of 2, Patricia? Okay. What'd you get? Yes? 0.2240. How about P of 3? About P of 3? Say it, JC. Say it. Say it. No. Don't trip out. Just say it. That is correct. No. All right. Yeah, we get the same for both P2, P3. And what do we do with all these? Tell your neighbor. Yeah, find the sum. So, 0 point what? Are you guys going to make me add vertically? My goodness. Oh, yeah? Okay. Thank you. All right. Not bad. So this is where it's going to get interesting. Ready? You're like, it hasn't been interesting. Be nice. Here, let's go to the next one. It says, at least 3 calls. What does that mean? Talk it over to your neighbor. Three, ... and we don't know how many more. Is that correct? Do you guys want to do P3, P4, P5, P6, P7, P8? You guys don't want to do that? What? Okay, so then you're going to have to put your brains together, because if not, you are going to have to do that for home plate. Question. If at most is from 0, 1, 2, and 3 gives us this, at least means from 3 and on, what can we do to save time using some of the stuff that we used over here and that? Talk it over to your neighbor. What can we do? Yeah, tell your neighbor, what's the limit for this probability? No. Who's got it? Anyone? What shall we do? Let's see, any ideas? Zach, what do you think? Wow. Help us out, Presidenta. Any ideas? Okay. Here it goes. Y'all ready? So this is from 3 and on. Is that correct? So that probability of 3 and on together with the probability of 0, 1, and 2, how much is that supposed to add? What would be the sum of the probability of? It would be 1. Yes. So what do? We get 0, 1, 2, and then subtract that from what? From 1. 1 minus P of 0, 1, and 2, and that should give us the probability of at least 3 calls. Let's go! So, does that make sense, guys? I mean, P of 0, 1, and 2. Do we have that work already? Yeah, it's here, here, and here. Who can give me that? Am I going to have to add vertically again? Oh, my goodness. Is it 6332? 0.66332? No? Oh, my bad. I added one more. 0.4232. Yeah. 0.432. 232. Oh. My goodness. Like that? Yeah. All right. Therefore, that is correct. That is the probability of at least 3 calls. Okay, so in that, thinking in those terms, think about it. What does this mean? Tell your neighbor, please. What does that mean? That it's from 5 and on, right? 5 and on plus what gives us 1? P of what? 0, 1, 2, 3, and 4. So that means we need to find one more, right? Aside from these, subtract it from 1, and that gives us the P of 5. All right, I'm gonna stop right there. You guys, I'll let you guys do the computation for that last one, because you only need to find one more, and then just add all of these to that. Yes? Yes, Mr. Q. All right. So home plate for tonight. Take a screenshot of that. Numbers 1 and 2. Some of you are like, Mr. Q, this was a bit challenging. Yes, I know. But we got to do it. We got to do it. All right, I'll stop the video right there. Enjoy your home play. Bye.